Welcome to Math with Mr. J.
In this video, I'm going to go through an introduction to combining like terms. Now remember, like terms are terms with the same variables to the same powers. When we combine like terms, we look for any like terms in the given algebraic expression and combine them into one term. By combining like terms, we can simplify expressions. That just means we can rewrite the original expression in a simpler and easier way to understand and work with. Let's jump into number 1, where we have 9x plus 3x. We will start with this basic expression and work our way up. So we have two terms in this expression, 9x and 3x. Both terms have the same variable of x, and these variables of x are to the same power. Remember, when we don't have an exponent attached to a variable, there is an understood exponent of 1. Anything to the power of 1 is just itself. So 9x and 3x are like terms. Now, when we combine like terms, all we need to do is add or subtract the coefficients, the numbers in front of the variables. The coefficients in number 1 are 9 and 3. We have a positive 9x plus a positive 3x, so let's add those coefficients. 9 plus 3 is 12, and then we have the variable of x. And that's it. We took those two like terms, 9x and 3x, and combined them into one term, 12x. 12x is equivalent to 9x plus 3x, so we didn't change the value of the expression. So 12x is our final simplified expression. Let's move on to number 2, where we have 8g plus 7 plus 5g plus 2. Are there any like terms that we can combine in order to simplify this expression? Yes, we have 8g and 5g. Both of those terms have that variable of g. And then we have constant terms, 7 and 2. I'll box in the constant terms to separate them from the 8g and the 5g. Now we can combine like terms. We have 8g plus 5g. That gives us 13g. And then we have 7 plus 2. That gives us 9. So we end up with 13g plus 9. And that's our simplified expression. That expression of 13g plus 9 is equivalent to the original expression. We were just able to simplify the original expression by combining like terms. We started with 4 total terms, but we were able to combine like terms, and now we only have 2 total terms. Let's move on to number 3, where we have 6y squared plus 10y plus 2y squared plus 3y plus y. Let's find any like terms that we can combine. We'll start with 6y squared. 2y squared is a like term. Both of those terms have that variable of y to the power of 2. Now, do we have any other like terms within this algebraic expression that we can combine? Yes, 10y. And I will box these terms in order to separate them from the y squared terms. 3y. And then y. Now I do want to mention this term right here, the y, the variable by itself, the coefficient is 1. We don't have a coefficient written in front. Whenever you see that, the coefficient is 1. There is an understood 1 in front of a variable, and it can be helpful to write that 1 in there when you combine like terms. So you can always write that 1 if you would like. Now, since this algebraic expression has 5 terms and we are working our way up to more complicated algebraic expressions, we're going to use a strategy to help us organize the expression before we combine like terms. We are going to rearrange and rewrite the expression and put the like terms next to each other. I'll start with 6y squared plus the like term of 2y squared plus, now we have the y terms, so 10y plus 3y plus 1y. So now all of the like terms are next to each other, and it's a little easier to see what we can combine. So this is a strategy to keep in mind. Now, do you have to do this step in order to combine like terms? No, but it can be helpful. Now we can combine like terms. We will start with 6y squared plus 2y squared. So add the coefficients. 6 plus 2 is 8. And then we have y squared plus, now we can combine the y terms. So we have 10 plus 3 plus 1. 10 plus 3 is 13, plus 1 is 14. So we get 8y squared plus 14y. And that's the simplified expression. We now have an equivalent expression that is simpler than the original. We simplified the expression. We went from 5 terms to 2 terms. Let's move on to number 4, where we have 7x plus 2y minus 4x plus 2y. Let's find any like terms that we can combine. We will start with 7x and negative 4x. Now, when we combine like terms, a term is going to take the sign that's in front of it. So this is negative 4x. Then we have 2y and 2y. So let's box those terms in order to separate them from the x terms. Now we can rewrite this expression with the like terms next to each other. We will start with 7x minus 4x. So we have a negative 4x there. Make sure to bring the sign that's in front of the term with it when we rewrite the expression. Plus 2y, so now we have the y terms, plus another 2y. Now we can combine like terms. So we have 7x minus 4x, or you can think of this as 7x being combined with negative 4x, however you want to think about it. 7 minus 4 is 3, and then we have the x, or if you're thinking about it as 7x combined with a negative 4x, 7 and negative 4 give us 3 as well. Then we have our 2y plus 2y, that gives us plus 4y. So we end up with 3x plus 4y, and that's our simplified expression. We went from 4 total terms to 2 total terms by combining like terms. 3x plus 4y is equivalent to the original expression. We were just able to, again, simplify this expression by combining like terms. Now, I also want to go through simplifying this expression a slightly different way to start off, and that's by rewriting the original expression with only addition separating the terms. We do this by changing any subtraction to adding the opposite. The benefit of having all terms separated only by addition is that it's a little simpler to identify all of the terms, especially any negative terms. It kind of organizes the expression and helps any negatives stand out. I'll rewrite the expression off to the side here. So 7x plus 2y minus 4x plus 2y. So let's rewrite subtraction as adding the opposite. So adding the opposite of a positive 4x is a negative 4x. So adding the opposite. Let's rewrite the expression with that change. So we have 7x plus 2y plus negative 4x plus 2y. Let's rewrite that expression with like terms next to each other. So 7x plus negative 4x plus 2y plus 2y. Now we can combine like terms. We have 7x plus negative 4x. That gives us 3x. And then we have 2y plus 2y. So that gives us plus 4y. 3x plus 4y that way as well. So that's just another strategy to be aware of. So you have it. There's an introduction to combining like terms. I hope that helped.
Let's say that I've got two Chuck Norrises, or maybe it's Chuck Norri, and to that I am going to add another 3 Chuck Norrises. So I'm going to add another 3 Chuck Norrises, and this might seem a little bit obvious, but how many Chuck Norrises do I now have? Well, 2 Chuck Norrises, we can represent this as literally a Chuck Norris plus a Chuck Norris. So let me do that. A Chuck Norris plus another Chuck Norris. 2 Chuck Norrises, you could also view this as 2 times Chuck Norris, and this is just another way of representing it. And 3 Chuck Norrises, you could view that as a Chuck Norris plus a Chuck Norris plus another Chuck Norris. And so we would have a grand total, and this might be very simple for you, but you would have a grand total of 1, 2, 3, 4, 5 Chuck Norrises. So this would be equal to 5 Chuck Norrises. Now let's get a little bit more abstract here. Chuck Norris is a very tangible thing. So let's go to a little bit more of traditional algebraic notation. If I have two x's, and remember, 2x, this is what you could do this as 2x's or 2 times x, and to that I were to add 3x's, and to that I would add 3x's. How many x's do I have? Well, once again, 2x's, that's 2 times x. You could view that as an x plus an x. We don't know what the value of x is, but whatever that value is, we can add it to itself. And then 3x's are going to be that value. I'm doing that same green color. 3x's are going to be that value plus whatever that value is. And so how many x's do I now have? Well, I'm going to have 1, 2, 3, 4, 5 x's. So 2x plus 3x is equal to 5x. And if you think about it, all we really did, and hopefully you conceptually get it, is we just added the two numbers that were multiplying the x. And these numbers, the 2 or the 3, they're called coefficients. Very fancy word, but it's just this constant number, this regular number that's multiplied by the variable. You just added the 2 and the 3 to get your 5x. Now let's think about this a little bit more. Let's go back to this original expression, the 2 Chuck Norrises plus 3 Chuck Norrises. Let's say to that we were to add, some type of a, let's say we were to add 7 plums over here. So this is my drawing of a plum. So we have 7 plums plus 2 Chuck Norrises plus 3 Chuck Norrises. And let's say that I add another 2 plums. Here. So what would this whole thing be? Well, I wouldn't add the 7 to the 2 to the 3 plus the 2. We're adding different things here. You have 2 Chuck Norrises and 3 Chuck Norrises, so they're still going to simplify to 5 Chuck Norrises. And then we would separately think about the plums. We have 7 plums, and we're adding another 2 plums. We're going to have 9 plums plus 9 plums. So this simplifies to 5 Chuck Norrises and 9 plums. Similarly, over here, if I had, instead of just 2x plus 3x, if I had 7y plus 2x plus 3x plus 2y, what do I now have? Well, I can't add the x's and the y's. They could very well represent a different number. So all I can do is really add the x's, and then I get the 5x, and then I'd separately add the y. If I have 7 y's, and to that I add 2 y's, I'm going to have 9 y's. If I have 7 of something and I add 2 of something, I now have 9 of that something. So I'm going to have 9 y's. So you add that, and then a different color. You add this and this, you get that. You add the x's, you get that right over there. So hopefully that makes a little sense. Actually, I'll throw out one more idea. So given this, what would happen if I were to have 2x plus 1 plus 7x plus 5? Well, once again, you might be tempted to add the 2 plus the 1, but they're adding different things. These are 2 x's. This is just the number 1. So you really just have to add the x's together. So you're going to say, well, I got 2 x's, and I'm going to add 7 x's to that. Well, that means I now have 9 x's. And then separately, you would say, well, I've got just the abstract number 1, and then I got another 5. 1 plus 5 is going to be equal to 6.
Welcome to Math with Mr. J.
In this video, I'm going to go through how to simplify expressions by combining like terms. Now remember, like terms are terms with the same variables to the same powers. When we combine like terms, we look for any like terms in the given algebraic expression and combine them into one term. By combining like terms, we can simplify an expression. That just means that we can rewrite the original expression in a simpler and easier way to understand and work with. Let's jump into number 1, where we have 9c plus 6d plus 5d plus 8c plus 2d. The first thing that we need to do is identify any like terms that we can combine. So are there any like terms that we can combine in this expression? Yes. Let's start with 9c and 8c. Both of those terms have the same variable to the same power. Both terms have the same variable of c to the same understood power of 1. So they are like terms. Remember, when we don't have an exponent attached to a variable, there is an understood exponent of 1. Something is to the power of 1. Anything to the power of 1 is just itself. We have any other like terms that we can combine? Yes, we have 6d, 5d, and 2d. All of those terms have the same variable of d to the same understood power of 1. So let's box those terms in order to separate them from the other terms. Are there any other like terms that we can combine? No, all of the like terms have been identified. So what we can do now, we can rewrite this expression with the like terms next to each other. By rewriting this expression with all of the like terms next to each other, this will help us organize the expression. It will make combining like terms a little simpler. We have 9c plus 8c plus 6d plus 5d plus 2d. So now all of the like terms are next to each other, and it's a little easier to see what we need to combine. So this is a strategy to keep in mind. Now, do we have to do this step in order to combine like terms? No, but it can be helpful. Now we can combine like terms. Let's start with 9c and 8c. So we have 9c plus 8c. We need to add the coefficients, the numbers in front of the variables. So we have 9 plus 8, which is 17. So we have 17c plus, and now we can combine these terms. So we have 6d plus 5d plus 2d. 6 plus 5 is 11, plus 2 is 13. So we have 13d. And this is our final simplified expression, 17c plus 13d. Now, 17c plus 13d is equivalent to the original expression. We went from 5 total terms in the original expression and simplified it to 2 total terms by combining like terms. Let's move on to number 2, where we have negative 10a plus 2ab plus 9a plus ab plus 9a minus 8. Let's start by identifying any like terms that we can combine. So do we have any like terms that we can combine? Yes, we have negative 10a and 9a and another 9a. All 3 of those terms have the same variable to the same power, the variable of a to the understood power of 1. Do we have any other like terms that we can combine? Yes, we have 2ab. Let's box these in order to separate them, and then ab. Now this term right here, ab, does not have a coefficient written in front. Whenever we see this, there is an understood coefficient of 1. So this is 1ab. And we're able to write that 1 in as the coefficient. And it's helpful to do so when combining like terms. That way you know you need to combine that 1. Are there any other like terms within this expression that we can combine? No, but we do have one more term, negative 8. So we have a constant term of negative 8. And I'll circle that term in order to separate it. Even though we don't have anything to combine it with, we still need to include it in the simplified expression. and that is -8. Remember, a term will take the sign that's in front of it. So we have -8 and -10a within this expression. Now we can rewrite this expression with the like terms next to each other. We have -10a plus 9a plus 9a plus 2ab plus 1ab minus 8. Now we can combine like terms. Let's start with -10a plus 9a plus 9a. -10 plus 9 is -1, plus 9 is 8, a positive 8. So we have 8a, and then plus 2ab plus 1ab. 2 plus 1 is 3, so we have 3ab. And then lastly, we have a -8 or -8 here. So 8a plus 3ab minus 8 is our final simplified expression. We went from 6 total terms in the original expression to 3 total terms in the simplified expression by combining like terms. Let's move on to numbers 3 and 4, where we actually have the same exact expression, 4x squared minus 7 plus 3x minus 2x squared plus 3. We're going to go through this two slightly different ways. First, we will go through simplifying the expression as it currently is, and that's for number 3. For number 4, we're going to rewrite the expression so all of the terms are separated only by addition. We will talk more about that strategy once we get to number 4. Let's start number 3 by identifying any like terms. So do we have any like terms that we can combine? Yes, we have 4x squared and -2x squared. Both of these terms have the same variable of x to the same power of 2. So 4x squared and -2x squared. Remember, a term takes the sign that's in front of it, so that's -2x squared. Do we have any other like terms that we can combine? Yes, we have two constant terms, -7 and 3. I'll box those terms in order to separate them. And then lastly, we have 3x. We don't have any like terms to combine 3x with, but I will circle it in order to separate it from the other terms. Now we can rewrite this expression with the like terms next to each other. Remember, bring the sign that's in front of the term with it as you rewrite this expression. So we have 4x squared, and then -2x squared is the like term. So this is going to be 4x squared minus 2x squared. Then we have plus 3x, and then our constant terms last. So we have -7, a -7, plus 3. Now we can combine like terms. We have 4x squared minus 2x squared, or you can think of this as combining 4x squared and -2x squared. However you want to think about it, you'll get the same thing either way. Let's subtract the coefficients. We have 4 minus 2, which gives us 2. Or if you thought about it as 4 combined with -2, that gives us 2 as well. So this is 2x squared. Then we have plus 3x. And then we can combine -7 and 3, positive 3. So we have -7 plus 3. That gives us -4. So our final simplified expression is 2x squared plus 3x minus 4. We went from 5 total terms in the original expression to 3 total terms by combining like terms. Let's move on to number 4, where we will take a look at a strategy we can use when we have subtraction or negatives involved in the expression. We're going to rewrite the original expression with only addition separating the terms. The benefit of having all terms separated only by addition is that it's a little simpler to identify all of the terms, especially any negative terms. It kind of organizes the expression and helps any negatives stand out. Now, do you have to use this strategy? No, but it can be helpful, so I wanted to at least go over it. So let's rewrite this expression with only addition separating the terms. We do this by adding the opposite, so change any subtraction to adding the opposite. Let's change this to addition, and then the opposite of positive 7 is negative 7, so add the opposite. Then let's add the opposite here as well, so the opposite of positive 2x squared is negative 2x squared. So let's rewrite this with those changes. So we have 4x squared plus negative 7 plus 3x plus negative 2x squared plus 3. So now all of the terms are separated only by addition. Now we can identify any like terms. We have 4x squared and negative 2x squared. Then we have negative 7 and 3, and then 3x. Now let's rewrite this expression with the like terms next to each other. So we have 4x squared plus negative 2x squared plus 3x plus negative 7 plus 3. Now we can combine like terms. We have 4x squared plus negative 2x squared. 4 plus negative 2 is 2, so we have 2x squared plus 3x plus negative 7 plus 3. Negative 7 plus 3 is negative 4, so plus negative 4. Now this is correct, but we can clean this up a little bit, so to speak. We have a double sign. We are adding a negative 4. Adding a negative 4 is the same as subtracting 4. We are decreasing in value by 4. So we can rewrite this with just one sign. We don't need both of those signs. When we add a negative, that's the same as just subtracting a positive. So let's change this to subtracting 4. And again, getting rid of the double sign will make this a little simpler. It will clean it up. We can rewrite this as 2x squared plus 3x minus 4. And that's our final simplified expression. So you can see that we got the same exact simplified expression for number 3 and 4. Just slightly different strategies as far as organizing the expression to start. Now I do want to mention one last thing, and it's about writing out expressions. When we write an expression, we typically want any exponents first. If there are multiple exponents, write them from greatest to least. If we have the same exponent, go in ABC order. And then constant terms always come last. So for example, in number 1, we have the variables of C and D. Both are to the understood power of 1, so we go in ABC order. For number 2, we have A and AB. Everything here is to the understood power of 1, so we go in ABC order. A comes first, then AB, and then the constant term comes last. For numbers 3 and 4, we have x squared, so the greatest exponent, 2. Then we have the variable of x to the understood power of 1. And then lastly, we have the constant term. So something to keep in mind when you are writing expressions. So there you have it. There's how to simplify expressions by combining like terms. I hope that helped. Thanks so much for watching.
Okay. What I'm about to send you is a link. You need to click on that link. That is a guided practice sheet that we're going to start here in a second. Let me show you what it looks like. Okay, so that's the sheet you should have. You're going to want to either print that or you're going to want to have that up where you can see it. We're going to work through it together. Let me also remind you that you're supposed to have your camera on. Those of you that are new, it is a requirement now. And here's what we're going to do. We're going to be working through this sheet. I'm going to pull my camera up in just a minute and you'll see that I have my sheet out and I'm going to be working on it. I'm going to be asking questions. I don't want anybody to respond until I call on you. Okay, so don't be shouting out answers. Don't be dropping answers in the chat box until I call on you. And I'm going to be randomly calling on folks as I ask questions as we're working through this. All right, so let me switch. Switch to my camera. All right, so you should be seeing my camera. It may take a second for it to pop up on the screen. All right. All right, is there anyone that cannot see my camera with my worksheet, my hand, my big old fat hand is out here on it with my big blue marker? Everybody should see that. If you can't see that, you need to be letting me know. Okay, so again, don't call out answers. Okay, then Brittany, you probably need to log out, log back in. Sometimes it just, when I switch to something new, it may cause your computer to flake out a little bit. So again, don't call out answers. I'm going to be calling on you. So I'm going to work through the first few of these. You follow along. I'm not going to ask any questions yet until we get down to about number 4 or 5. So I'm going to work these first. You follow along with me. So on number 1, we have 2 terms. Each of these is called a term. Terms are separated by plus or minus sign. In the first term, we're taking the coefficient, that's what we call the number in front of the variable. We're taking the coefficient 4 and multiplying it by the variable d. When you see 4d, that means 4 times d. Plus, we're taking the coefficient 5 and multiplying it by the variable d. Since both of these terms have the same variable to the same power, because there's an understood power of 1 right there that we don't write, then I can put these terms together. So if you'll recall the video where they had 4 Chuck Norrises and 3 Britney Spears or whatever it was, if they're different variables, we can't put them together. But if they're the same variable, we can put these together. So if I have 4 D's and 5 D's, I have 9 D's. On number 2, I have 3 terms, 12y, 1y, and negative 5y. So here I have 3 terms. And because all 3 terms had the same variable to the same power, y to the first, y to the first, y to the first, then I can put these together. If I add the first 2 of these together, 12y, and there's an understood 1 in front of that y, 12y and 1y would be 13y minus 5y. And now here's why we've been doing those, or we had that review with the adding and subtracting integers. And those of you that have been in the class, you see why everything we've been doing comes back. Every single thing that we do, you're going to use again later on somewhere. So a positive 13 and a negative 5 gives me 8y. So I can put those together and combine all of those terms and get 8y. All right, let's look at number 3. Again, I have 3 terms, 10p, 2p, 3p. There's 3 terms. All 3 of those terms are like terms. They're like terms because they have the same variable to the same power of 1. So I can put those together. 10 plus 2 is 12. 12 plus 3 is 15p. Now, when we move to number 4, we have something a little bit different. On number 4, we still have 3 terms, 6r, negative 1r, and a positive 4. We still have 3 terms. 1, 2, 3 terms. 3 pieces that are being either added or subtracted together. But we only have 2 sets of like terms. 6r and negative r are like terms because they have the same variable to the same power. But 4 doesn't have an r, so I can't put that 4 with the 6 and the negative 1. That is called a constant. I can't combine it with the r's. So this will simplify. 6r minus an r gives me 5r, but I can't put that 4 with anything. It won't combine with anything, so it's left over. So 6r minus r plus 4 combine together to give us 5r plus 4. Anybody have any questions at this point? Okay, hopefully this is making sense. This is very, very important. All right, let's move to number 5. Now I'm going to start asking some questions. Okay, well, we're going to continue to go through it, Mr. Green. And I'm sure that you're not the only one. Okay, so I'm going to start asking some individual questions. I'm going to start calling on folks. Mr. Floyd, I want to know in number 5, how many terms are there? How many terms are in number 5, Mr. Floyd?
There are 3 terms.
You're close. There are 3 like terms. That 5 is also a term. So we have 15, -1, -3, 15W, -1W, -3W, and -5. Each of those is a term. So any of the pieces that are being added or subtracted count as terms. But only 3 of those are like terms. Okay? The 3 that are like terms are the 15W, the -1W, and the -3W. So there are actually 4 terms, but there are only 3 that are like terms. So 3 are like terms. All right. Miss Kelly, if I combine these first 2 together, 15W minus W, what will I get? Miss Kelly.
14.
14.
W.
Very good, 14W. Okay, so when we combine 15W and a -1W, those combine to give me 14W. We still have -3W minus 5. And so now we've got to put the 14W and the -3W together. So we still have to combine those 2 like terms. Mr. Quinn, what do we get if we combine 14W and -3W? Mr. Quinn. 11W, very good, that's exactly right. Minus 5. We cannot put the 5 with the W because there is no W with that -5. If there was, then we can combine those. So this ends up being our final answer. We combined the 15, the -1, and the -3 W's, but we couldn't put the -5 together because it doesn't have a W with it. All right, let's move to number 6. Move to number 6. Mr. Roberts, how many terms are there? How many terms are there, Mr. Roberts? 4. Very good. That's exactly right. 8R, 6, 9R, and -3 are all terms. Each piece that's being added or subtracted are called terms. But there are only 2 sets of like terms. Only 2 sets of like terms. Only 2 sets of like terms. Miss Carter, what is one of the sets of like terms, Miss Carter? One of the sets. Very good. 8R and 9R. Those are one of the sets of like terms. So I can put those together. I can combine those because they are like terms. They have the same variable to the same power. All right. And so Miss Allman, what do I get if I combine 8R and 9R? Miss Allman. Very good. 17R. We're combining the 8 and the 9. So we're combining the coefficients, the numbers in front, and keeping the R. It's sort of like having 8 raisins and 9 raisins. You have 17 raisins. And now we need to combine this 6 and the -3. The 6 and the -3. Mr. Brown, what would we get if we combine +6 and -3? +6 and -3, Mr. Brown. +6 and -3, Mr. Brown. How about Mr. Nichols? Mr. Nichols, what do we get if we combine 6? Very good. We get +3. The +6 and the -3 give us +3. +6 and -3 add up to give us +3. All right, let's look at number 7. On number 7, we have a 7x, a -1x, and a 9y. 7x, -1x, and 9y. Miss Paget, what is one set of like terms? One set of like terms. We have 3 terms. I want to know what is a set of like terms. 7x, and careful. Careful, go back and look at that. It's 7x, but it's not 1x. It's because if you say 1x, there we go. There you go. 7x and -1x. 7x and -1x. Okay. All right. If we put 7x and -1x together, we put 7x and -1x together. Ms. Dishman, what would we get if we put together 7x and -1x? Ms. Dishman. Careful, a little bit more. Not just 6. Not just 6. It's 6. Nope, it's positive. but you're leaving off the most important part. Well, not the most important part, but a very integral part. 7x and -1. There you go. That's what I'm looking for. 6x. So those combine together to give me 6x, and we're left with 9y. There is nothing to combine the 9y with. And just as they said in the video, we put them in alphabetical order. So x comes before y. The x term we typically write first. Okay. All right, number 8. I want you to try number 8 by yourself, and then I'm going to call on somebody to tell me what they got for their answer. Try number 8 on your own, and I'm going to call on somebody to give me the answer. Okay, thank you. And we're going to take a break in just a minute, so because I've been drinking coffee and I'm going to have to go. Okay, we're working on number 8. 2a plus 6a plus 5b minus 3b. Want to put those together, like terms together. And I want to know what you get for a final answer, and I'm going to call on somebody to tell me what they got. How about Mr. Hall? What did you get for an answer if you're done?
For number 8?
Yes.
So, like, it's pretty much already simplified with the like terms and everything. They're both beside each other. So I just did 2a plus 6a and got 8a. And then 5b minus 3b is 2b. So that gives you the final answer of 8a plus 2b.
Very good. Yes. Very good. Thank you. So he took 2a and 6a. Those two are like terms because they have the same variable to the same power. Put those together and got 8a. Then he took 5b and -3b. Both of those are like terms because they have the same variable to the same power. Put those together and got 2b. Okay. All right, here's what we're going to do. I'm going to send you the link to a sheet that's just like this. Okay. And this is a good time for you to take a break. I have that it's 10:07, so I would like you back at 10:30, and I'm going to want to know how much of this sheet you have completed. Let me get it to you here, just 1 second. All right. I'm going to show you the answers so that you can check your work and see if you have any questions. Okay, so there's 1 through 12. Take a look at those. If you've missed one, look and see if you can see where your mistake is at. If not, and you want me to work it, I will ask for questions here in a few minutes. Don't let me know now, but after we've checked all of the answers, I'll then ask if there's anybody that wants me to work one of those or any of those. But I want you to see if you can see your mistake first. I'm going to scroll down. There's through 15. All right, I'm going to scroll down some more, let you see into the challenge problems. And now the last ones. All right, you should have been able to check all of your answers. Hopefully you've seen where you made your mistake. If you missed one, are there any of these that you would like for me to work? Any of these that you want me to work? Number 3. All right. I'm going to switch this off. All the challenge ones? Okay, I'll do that. I'm going to turn this off. And I'm going to switch to camera. All right, hopefully you can see my camera now. Again, sometimes it takes 45 seconds to a minute for it to finally pop up, depending on your internet connection. All right, so I was asked to do number 3. So number 3, we have 3 terms, 14C, 6, which is a constant term. It does not have a variable, and negative 8C. So 14C and negative 8C are like terms. They have the same variable or variables to the same power. Both of those terms have a c variable, and c is to the first power, understood first power. So we can put the 14 and the -8 together. And so if I take 14 and subtract 8, I'm going to get 6c. 14c minus 8c is 6c. Then we have the constant term of 6 left over that we cannot combine with anything. We can't put that together. And so 6c plus 6 is our final answer. So the two c terms could be combined, but the 6 could not. Down here on the challenge problems, they threw some things in here on you. In order to be like terms, you have to have the same variable or variables. So you could have something that's got two variables, but they also have to have the same power or powers. So when I look here, I have a term that is 11j cubed and another term that's 4j cubed. Those two terms have the same variable to the same power, so these can be put together. So 11 and 4 is 15j cubed. On number 17, again, we have two terms. Both of those have an h term that's being squared. And so those are like terms because they have the same variables to the same powers. So the 14 and the -6 can be put together, and that gives me 8h squared. 8h squared. Okay. Then for number 18, on this one, we have a 7c term, we have a 4d squared term, and we have a -1d squared term. There's an understood 1 there. So if we do this in alphabetical order, the 7c doesn't have another term to combine with, so it's just left over as 7c. But the d terms both have d squared, so they can be put together. So we have a 4 and a -1. That gives me +3d squared. On number 19, we have p's and r's. The 9p squared and the -3p squared. Both of those are like terms because they have the same variable to the same power. So 9 minus 3 gives me 6p squared. And then the 13r doesn't have anything to combine with it, so it's by itself. On number 20, here we have some k squared terms, and we have some m cubed terms. 16k squared and -7k squared are like terms because they have the same variable to the same power. So we get 9k squared. And then 5m cubed and 6m cubed, those can be combined because they have the same variable to the same power. And so we get 11m cubed. Excuse me. And then on number 21, we have a 17e squared and no other e squared, so that's by itself. We have a 15f cubed and an -11f cubed. Those can be put together because they have the same variable to the same power. And so 15 minus 11 is 4, excuse me, 4f cubed. And then we have this negative 18 sitting here left over. And so there's nothing to combine it with. So we get negative 18. So that simplifies to 17e squared plus 4f cubed minus 18. Okay. Were there any others that you wanted to work? You're going to see in a minute why this is so important. All right. So today was about two different things. One was learning how to do combining like terms. The other is a review of solving equations. So you need to get your notebook out because you need to work these equations along with me. We're picking up where we left off from before the summer break. So some of you are new. This will be new to you. And so that's why I'm doing a bit of a review, because you're going to have some of these to do for your assignment. We are solving equations. So when we started this journey on solving equations, we started with what we called one-step equations that look like this. And we want to solve for x. Now you can look at that problem and say, oh, I know the answer to that. X has got to be 9 because 9 minus 5 is 4. Yes, that's true. That's very true. And I'm glad you can look at that and see that the answer would be 9. But you have to learn the process. If you don't learn the process, you will not be able to do the problems that are coming, that are down the road. So we're going to learn the process. The process is to take our fundamental order of operations. We reviewed that on Tuesday. Please excuse my dear Aunt Sally. And we work backwards. We work backwards on the fundamental order of operations. So we undo any addition or subtraction to the variable. We're trying to get x to be by itself on one side of the equal sign. So we're going to work this problem down page so that we end up with x equals something at the end. So I'm looking at the x, and I see that I am subtracting 5 from the x. So I need to undo that subtraction. The way I do that is I add 5 to that side, because minus 5 plus 5 becomes 0. We're trying to get rid of stuff that's on the left side of the equation with the x. And just like with fractions, when you do something to the bottom of the fraction, you have to do the same thing to the top. And so since I added 5 to this side of the equation, I must add 5 to that side of the equation. On the left side, these add out. They become 0. Negative 5 plus 5 is 0. That's the whole reason for doing that. And so what's left on this side is x. On this side, x plus 4 plus 5 is 9. I can always check my solution to an equation by plugging it back in, the value that I get, plugging it back into the original equation. So if I take x minus 5 equals 4, and I put the 9 in here for x, 9 minus 5 equals 4. 9 minus 5 is 4. Both sides of the equal sign are the same. And so this is the solution to that equation. When you solve an equation, you should write exactly what I wrote. Your paper should look exactly like this right here, because I want you to learn the process. Trust me, if you follow my steps and do it the way I am showing you, you will be able to do the problems that we do in the future. Okay? So, learn the process. I taught high school math for almost 20 years. I know what I'm talking about. So, follow my steps and learn to do it the way I'm showing you how to do it. All right, let's look at another equation. If I have 8 equals x plus 3, again, I hope you can look at that and tell that the answer is going to be 5. 5 plus 3 is 8. But we need to learn the process. The process is what's important, not that you can just look at that and see that x is going to be 5. So again, we have to take our fundamental order of operations. Please excuse my dear Aunt Sally. And we undo addition or subtraction first. So we look at the variable and we see that we are adding 3 to that variable. To undo that, I have to subtract 3 so that this becomes 0. That's the whole idea, is for that side, for everything to go away except the x. If I subtract 3 on the right, then I have to subtract 3 on the left. Your paper should look exactly like that right now. If I had you take a picture of your paper and send it to me, I would want to see that right there. I don't want you to take shortcuts. So on the left, 8 minus 3 is 5. And over here, 3 and negative 3 add out, and we're left with x. Okay. Now, when you were in school, you may have learned to solve this way. Your teacher may have taught you to write underneath it. Subtract 3, subtract 3. The 3's here add out, and we're left with x. And over here, 8 minus 3 is 5. We got the same answer. I do not like that. I do not teach it that way. The reason is, further down the line, you're going to get this line confused with division. Trust me, I have been doing this for years and years and years. See all this gray hair? I've been doing it for a long time. I know what I'm talking about. Trust me. All right. So we started with these type of equations. Then we moved to this kind of equation. 2x equals 8. Well, this is a little bit different, but the process is the same. We again start with please excuse my dear Aunt Sally, and we work backwards. I look at my variable, x. This time, I'm not adding or subtracting anything to the x. The 2 is being multiplied by the x. Again, I should be able to look at that and say, oh, I know that x is going to be 4. 2 times 4 is 8. But we have to learn the process. So if we don't have any addition or subtraction to undo, but we do have multiplication to undo. To undo multiplication, you divide. So to get rid of this 2 being multiplied by the x, I need to divide this side by 2. If I do that on the left, I must do that on the right. Whatever you do to one side of the equation, you must do to the other side of the equation. Now I have a fraction that's 2x over 2. We can divide out the common factor. The common factor is 2. That's the whole reason for doing this. And what's left is x. On this side, we have the fraction 8 over 2. This means 8 divided by 2. If we take 8 and divide it by 2, we get 4. I can always check my answer by taking the value that I get and plugging it back in for x. 2 times 4 is 8. I get the same number on both sides, so this equation is solved for x correctly. Then we took a look at this. X divided by 3 equals 4. Again, we start with please excuse my dear Aunt Sally, and we work backwards. You start at the variable. You find the variable, and you look at what's being done to the variable. In this case, the x is being divided by 3. The way we undo division is you do the opposite. Just like when we were adding something, we did the opposite and subtracted it. If we were subtracting something, we did the opposite and added it. If we're multiplying by something, we divide by that. Here we're dividing by 3, so I have to multiply this x over 3 by 3, which is 3 over 1. If I do that on this side, I have to do that on this side. And I've got to show that I'm multiplying. Over here, this becomes 3x over 3, and this side becomes 12. Because 3 is now a common factor in this fraction, it will divide out, and we're left with x equals 12. I can check my answer by taking the 12 and plugging it back in. And I get 4 equals 4. So this is the solution to the equation. Again, your paper should look just like mine because you're learning the steps. You have to learn the steps. If you don't learn the steps, the problems down the road will be impossible for you. I will show you in a minute. Okay, so we had problems where the x had something being subtracted from it, and we did the opposite and added. We had equations where something was being added to the x. We did the opposite and subtracted. We had a problem where we were multiplying something by the x. We undid it with division. And here we had a problem where we were dividing something. X was being divided by something. We undid it by multiplying 3 times this. Okay, well, then after we spent time doing those, then we moved to this. 4x minus 5 equals 35. Now that may be a little bit harder to look at and determine what the correct answer is. Sometimes it's not as easy. But we're going to do the same process. Please excuse my dear Aunt Sally. We undo addition or subtraction first. So I look at my variable, x. I have something being multiplied by the x, and I have something where I'm taking 5 away. We undo the addition or subtraction first. So to get rid of this minus 5, I need to add 5, because negative 5 plus 5 becomes 0. And so then we're getting at least part of what's next to the x away from it. If I do that on this side, I must do the exact same thing on the other side. Notice too how I'm trying to keep my equal signs lined up as I move down the paper. That is important. That is important. Okay? So, on the left, negative 5 plus 5 adds out. That becomes 0, and we're left with 4x. On this side, 35 plus 5 becomes 40. So we're now a step closer to getting x by itself. We got rid of the minus 5. Now we got to get rid of the 4. Now we can do the multiplication or division part of it and get rid of it. So when I look at this and I look at x, we're multiplying 4 times x. We undo multiplication by dividing. Whatever you do on the left side of the equation, you must immediately do on the right side of the equation. I'm keeping my equal signs lined up as much as possible. On the left, the 4's will divide out. That's the whole reason for dividing by 4, is so that the common factor of 4 divides out. That's why we were learning how to take fractions like 15 over 20, and we were learning how to reduce them. The common factor in 15 over 20 is 5. 5 times 3 and 5 times 4. The 5's divide out. So do you see why we spent time weeks and weeks and weeks ago learning how to take fractions and reduce them? It's because you have to understand that concept of there being a common factor in the top and the bottom, so that when we get to this, you understand why I can divide the 4's out. They're common factors. They divide out. I'm simplifying this fraction. And so this becomes x, and this becomes 10. Okay? This becomes 10. We can check our answer by taking that 10 and plugging it back in. Four times 10 is 40. 40 minus 5 is 35. Both sides of the equal sign are the same. This is the solution to the equation because I checked it and it worked. Okay. Then after we did those kind of problems, we moved to this. 4 times x plus 3 equals 20. Now the problems are getting more complicated. There are more steps involved. For this problem, about maybe 2 weeks ago, 3 weeks ago, we learned something called the distributive property. The distributive property means take something outside the parentheses and multiply it by each thing inside the parentheses. So I take 4 and I multiply it by x and I get 4x. I take the 4 and multiply it by 3 and I get plus 12. So I took what was outside the parentheses and I distributed the 4 over the x and the 3. Well, now if you look at this, this looks just like this. So now we're back to the same kind of problem. Please excuse my dear Aunt Sally. And we work backwards. So I look at the x. I have a 4 that's being multiplied by the x. And I have a 12 that's being added to the x. I need to undo the 12 first. I need to get rid of this plus 12 on the left. So the way I do that is I subtract 12. If I subtract 12 on the left, I must subtract 12 on the right. Whatever you do on one side, you must do on the other. Again, notice I'm keeping my equal signs lined up as I move down the paper. The reason we subtracted 12 was so that this becomes 0 and adds out. That's the whole purpose. On the other side, when we subtracted 12, this becomes 8. Now we look at the x and we are multiplying the 4 times the x. So I need to undo the multiplication by dividing by 4. If I do that on the left, I have to do that on the right. The 4's divide out on the left side. And on the right, 8 divided by 4 is 2. I can check my answer by putting the 2 back in for the x. 2 plus 3 is 5. 4 times 5 is 20. This is the correct solution because it worked and I got the same value on both sides of the equal sign when I plugged my solution in for x. Do you see how every single thing we have learned comes back into play? You have to know how to add, subtract, multiply, and divide positive and negative numbers. You have to be able to work with fractions. You have to understand the fundamental order of operations. Please excuse my dear Aunt Sally. Okay, I've got another final example. Okay, let's see. So this example is 24 equals 3 times x minus 1. So this one's very similar to the last one, but this time the variable's on the right. That doesn't make any difference. The variable can be on either side. You're still trying to get x by itself. But I have parentheses. I need to get rid of those parentheses because otherwise I've got too much stuff going on here. So I use distributive property and I distribute the 3 over the x, which means I take 3 and multiply it by x and get 3x. And I take 3 and distribute it over -1 and get -3. 3 times -1 is -3. Now we have a problem that's similar to what number 5 and number 6 were. Please excuse my dear Aunt Sally. We're going to work backwards. We're going to undo addition or subtraction first. So I look at my variable. I'm multiplying by 3, and I'm subtracting 3. I need to undo this subtraction first. So in order to undo -3, I need to add 3. If I do that on the right, I must do that on the left. Whoops, plus. So I added 3 on the right. I need to add 3 on the left. Over here, the -3 plus 3 divide out, or add out, becomes 0. That's the whole reason for doing that. So we get 3x. On the left, 24 plus 3 is 27. Now we are multiplying by 3, so I need to undo the multiplication. I'm going to do that by dividing by 3. If I do that on the left, I must also do that on the right. Over here, the 3's divide out. That's why we did that. And we're left with x, which is what we want, x by itself. And so on the left, 27 divided by 3 is 9. I can check my answer by plugging it back in. 24 equals 3 times 9 minus 1. So 24 equals 3 times 9 minus 1 is 8. 24 equals 3 times 8 is 24. This solution works because when I plugged it back in for x in the original equation, I get the same number on both sides. Now I want to show you why I don't like to do the addition subtraction underneath, because this is a perfect problem to show you that. I'm going to start the problem back over again. And I'm going to distribute the 3. 3 times x is 3x. 3 times -1 is -3. You may have been taught in high school to add 3 on this side, add 3 on this side. Over here we get 27. Over here, these add out to give me 3x. Then we divide by 3 and divide by 3. The 3's divide out and we're left with x. And over here we get 9. Do you see how if I start drawing a bunch of lines on the problem, I'm going to start getting confused? So the only time I like to draw a line is when I'm actually doing division. And I do my adding and subtracting along the line of the equation instead of this mess of underneath. Again, if you'll do it the way I'm showing you, it will be easier for you, because let me show you what's coming. On Tuesday of next week, you will start solving equations that look like this. Much more complicated. The process is going to be exactly the same, because what we're going to do is take this side and do what we just learned how to do. I have a 3x and a -7x. I can combine my like terms. I have a +4 and a +3. I can combine those terms. 3x and -7x becomes -4x. 4 and +3 is +7. On this side, 9x and 4x becomes 13x. -7 and -9 becomes -16. and then we will go from there. On Thursday of next week, after we've done this on Tuesday, you will get problems that will start to look like this. Where there's a whole bunch of stuff on one side and maybe just as much stuff on the other side. If you don't learn the steps, you will never be able to get the right answer for these kinds of equations. So you have to trust me. You have to trust me. I'm not going to work this out yet because we're not there yet. But this kind of stuff is what you're going to see for your assignment. Okay, so let me show you your assignment. I'm not going to send it to you yet, but I'm going to let you see it. And I'm going to work the first couple of problems off of it with you. On the first one, we have 6 minus 8 equals 4. So I need to remember, please excuse my dear Aunt Sally, and we work backwards. So we look at our variable x. I am multiplying by 6, and I'm subtracting an 8. We undo addition or subtraction first. So in order to get rid of this minus 8, what do I need to do? What do I need to do? Y'all tell me in chat. What do I need to do? What's my first step? What am I going to do to both sides? Am I going to multiply by something? Am I going to divide by something? Am I going to subtract something? Am I going to add something? What am I going to do? Be careful. Look at where the X is. Look at where the X is. Look at what's being done to the X. We're multiplying by 6 and we're subtracting 8. We undo addition or subtraction first. So in order to fix this and start to get X by itself, most of you are saying add 8. That is correct. We take 6x minus 8 and we add 8 to both sides because I have the 6 is being multiplied by the x and we are subtracting 8. We undo addition or subtraction first on the side where the x is. So I don't do anything with the 4. I'm not concerned about that 4 yet. I have to get rid of what's over there by the x because the idea is to get x by itself, to isolate x by itself. So over here, those add up to 0. So I'm left with 6x. That's why we added 8, is because negative 8 plus 8 is 0. On the right side, 4 plus 8 is 12. Now we look at the x and we look at the 6 and we see that 6 is being multiplied by the x. What am I going to do next? Am I going to add something, subtract something, divide by something, multiply by something? What am I going to do next? So I hear divide by 6. Any other ideas? Come on, the rest of you need to chime in. What am I going to do to both sides? Am I adding something, subtracting something, dividing by something? Right, we're going to divide, and we're dividing by 6 because the 6 is being multiplied by the x. We always look at the x first. That is the focus point. You look at the x and you get rid of the stuff that's around the x. And so to get rid of this 6, we have to divide by 6. Whatever you do on the left, you must do the same thing on the right. Then these 6's divide out. That was the whole reason for doing that. And we get x. And on this side, 12 divided by 6 becomes 2. If we go back up here, 6 times 2 is 12. 12 minus 8 is 4. That works. Let's move to the next one on this side. 10j plus 5 equals 95. Our variable is j. We're trying to get j by itself. J by itself. So what am I going to do first on this one? Am I adding something, subtracting something, dividing by something, multiplying by something? What do I do first? Some of you are not participating. See, I keep a sheet. You can see on my camera of me down there, I keep a sheet that's a checklist of who's participating and who's not participating. And if you're not going to participate, you can go to the house. Okay, so good. Most of y'all are getting this right. We're subtracting 5 from both sides. So I'm going to have 10j plus 5 minus 5 equals 95 minus 5. I'm subtracting 5 from both sides of the equal sign, both sides. And so on the left, the reason we did that was so that the plus 5 minus 5 becomes 0 and disappears. And on the right side, 95 minus 5 is 90. Okay, so the first step was to subtract 5 from both sides. Now what are we going to do? And tell me don't just tell me multiply, divide, tell me by how much. So we're going to add something, subtract something, divide by something, multiply by something. What are we going to do next? Okay. We're going to divide by 10. We're going to take the 10j, divide it by 10, because the 10 is being multiplied by the j, and we need to get j alone. So to undo the multiplication, we divide. Those divide out. We're left with j, and 90 divided by 10 is 9. If we plug that back in, 9 times 10 is 90, plus 5 would be 95. All All right, and let's move to the third one across. This time we have parentheses. This time we have parentheses. We got to get rid of that parentheses first. So what are we going to do to both sides of the equal sign? I'm sorry. What are we going to do first? Because we've got to get rid of that parentheses. So what are we going to do to get rid of that parentheses? Okay, we cannot add G and 4 and get 4G because a G is a term by itself and 4 doesn't have a G. We can't put those together. There we go. That's what I'm looking for. We're going to distribute the 6. So those of you that are saying multiply by 6, I'm assuming that's what you mean. We're going to take the 6 and we have to multiply it by the G. And we have to take the 6 and multiply it by the 4. So 6 times G is 6G. And 6 times 4 is 24. So we take that 6 and distribute it over each term inside the parentheses. 6 times G, 6 times 4. Just like we were doing earlier today, we can't add G and 4. If that were G plus 4G, we could add those together. But we can't add G and 4 because those terms are not like terms. They have to have the same variable to the same power, and the 4 doesn't have a G with it. Okay, so we distributed the 6. What are we going to do to both sides on this one at this step? Okay, there are only about 4 or 5 of you answering. Let's get in here. Okay, good. We're going to subtract 24 because we're adding 24. We need to undo that. So 6G plus 24 minus 24. Whatever we do on the left, we must immediately do on the right. We subtract 24 because if we take positive 24 and negative 24 and put those together, they become 0. They cancel each other out. And so this disappears and we're left with 6G. And on this side, we have 42 minus 24. And that's what? 20. See, 16, 20, 30, 40, 16, 18. So 42 minus 24 is 18. Okay, so we subtracted both sides by 24. The 24 is added out. Now we have 6G equals 18. What are we going to do now to both sides of the equation? We have 6 times G. How are we going to get rid of that 6? Okay, good. We're going to divide by 6 on both sides. So on this side, the 6's divide out, and we're left with G. And on this side, 18 divided by 6 gives us 3. If we plug that back in, 3 plus 4 is 7, and 6 times 7 is 42. So that works. Okay, I'm going to do one more because this one has something just a tiny bit different, a little bit different, but the process is not any different. So here we have negative 2m plus 17 equals 27. We look at the variable m. We're multiplying by negative 2, and we're adding 17. We undo addition or subtraction first. So what are we going to do to both sides? Again, we got the same 3 or 4 of you that are participating. The rest of you got to chime in. Okay, Mr. Brown, but we need to look carefully. We are multiplying by negative 2. The negative 2 is being multiplied by the m. The 17 is being added. We add and subtract, or we get rid of addition or subtraction first. And so we have to get rid of this 17. So y'all are right. We need to take negative 2m plus 17 and subtract 17. And if I do that on that side, I have to do it on that side. We undo addition or subtraction first. Then we undo what's being multiplied. So over here, the purpose of doing that was so that that adds out, and I get negative 2m equals 27 minus 17 is 10. Now I am multiplying by negative 2. How do I get rid of that negative 2? Okay, correct. It's a negative 2 that we need to divide both sides because there's a negative sitting there. We got to get rid of everything that's over there. If we just divide by 2, we still have a negative left over. So we have to divide by negative 2. So that the negative 2's divide out, and then we have 10 divided by negative 2. 10 divided by negative 2 gives us negative 5. So we get negative 5 as our answer. So sometimes when we get down to that part of the problem, we have to divide by a negative number to get rid of that negative with the variable. The whole idea is to get the variable by itself. And everything you do, you're doing to get the variable by itself. You're slowly whittling away the pieces until the variable is sitting there by itself. That is the process. Okay. All right. Hopefully that wasn't. Hopefully y'all are getting it. Looks like y'all are catching on. I'm hoping that you are. We'll see when we do the assignment. And now, when you do the assignment, because you're going to turn this in on Tuesday, I don't want to see just a page with answers on it. That doesn't do me any good. Page of answers is completely worthless. I want to see your work, how you went through the process, and yours should look just like mine. If you will do it the way I'm showing you how to do it, when we get to the harder problems, you will be able to do those. They will make more sense because you learned the process with the easy ones. So you learn the process, and then the process gets applied to the harder ones, and the harder ones become easier to do. Again, I'm hoping that you're seeing how everything we've done comes right back into what we are doing. Okay? Everything we do comes right back to what we were doing. All right, somebody asked to see the first one again. Let me pull this back up. I'll let you look at the first one again. But everything we do is coming right back into what we are doing. And we're going to get to problems down the road where, in order to solve the problem, we've got to create the equation. The equation's not going to be given to you. You have to determine what the equation is and then solve it. So again, everything's going to build on each other. Probably, basically, from this point on, everything we do is going to be on how do we get the equation? And then how do we solve it? How do we set up the equation? And how do we solve it? So the next thing that's going to come after we've done this for next week, the week after, in 2 weeks, you won't have this. You will have a word problem. And we're going to have to take the word problem and build this from the words in the word problem, and then you'll solve it. So again, we've got to learn the process. If you learn the process with me and you'll do it the way I am showing you, it will be easier down the road. Again, see all this gray hair? You can see there's a bunch of gray hair in there. There's still a little bit of dark brown, but there's a lot of gray in there. I taught high school math for almost 20 years. And then I left the classroom and I started teaching teachers how to teach math in the classroom. And so I've been doing this for a long time. I'm an old man. I am old. I'm an old fart, like my kids tell me. Good. That's what I want to see. That you're catching on to this process. You're learning the steps, and hopefully you see that it's the same for every problem. The steps are exactly the same for every problem. If we look back here, we added or subtracted something. We added or subtracted something. Here we had to distribute first, so there was a little bit added to the problem beforehand, but then we were adding or subtracting something. And then after you do some adding or subtracting, you're doing some multiplying or dividing. The process ends up being exactly the same over and over and over and over again. We just add something to the beginning of it. Just like as I was showing you with this just as I was showing you with this, the only thing that's different here is now we got variables on both sides. And so what we will learn next week is, all right, well, if we've got variables on both sides, we don't want that. We want the variable by itself on one side. We're going to have to get rid of that variable on one side or the other. And it's going to be a matter of, instead of just subtracting a constant, we're going to subtract the variable term or add the variable term. For example, on this one, I can take this and I can take negative 4x plus 7 and add 4x. If I do that on that side, I do that on that side. And the reason that I did that was so that these add out. They're gone. Negative 4x and positive 4x becomes 0. Now I have the x's together on the same side. And now I can clump them together. 13x and 4x is 17x. I can clump those together. The process is the same over and over and over again. And the entire idea is to get the x so that it's by itself. So there may be x's on both sides. We got to get all of the x's on each side together. Then we've got to get the x's together on the same side. Then we got to combine them. And then we start saying, okay, what do we add or subtract from both sides? And then what do we multiply or divide by on both sides? We will take these complicated problems and whittle them down until they look like this or look like this. And then it's the same process over and over and over again. Okay? But this is going to be really hard if you don't learn this. Well, this. And showing the steps and writing it down. A lot of students like to say, oh, I don't need to write stuff down. I don't have to do that. I can do it without writing stuff down. Okay, big shot. What are you going to do when you get here and you're not writing stuff down? And typically the ones that say, oh, I don't have to write stuff down. I am a big shot. I don't have to write stuff down. And then they end up missing it. The ones that write the stuff down are the ones that don't miss it. And so there will probably be some of you, that's exactly what I'm going to tell you. I'm going to say, you're not writing the stuff down. You're getting it wrong because you're not writing the stuff down. Learn the steps, write the steps down, and you'll be able to do it as we move through and make the problems more complicated. Okay? All right. Y'all got me all worked up. That's good. I needed to get my blood pumping again.
If you liked this video, please click on the thumbs up. If you want to see more videos like this, please click on the subscribe button. And if you want to be notified when new videos are posted, please click the bell.